Hello and welcome to our lesson on finding equations of lines. This is going to be from section 2.7 in our text. We've got three formulas that you need to be aware of for this section. First, we have slope-intercept form. Slope-intercept form is useful if you're given the slope and the y-intercept, or the slope and any point in general. The slope-intercept form can be used to find the equation of a line. Next, we have the slope formula. This is needed if you're given two ordered pairs and you're asked to find the equation of the line. Because with 2 points on the line, you can use those to find the slope, and then you can either plug into slope-intercept form or point-slope form. And point-slope form is one of my personal favorites because it's useful if you know a point and the slope. So x1, y1 would be a point on the line, and m would be the slope of the line. In problem number 7, the instructions say, find a linear function whose graph has the given slope and y-intercept. Now, they come out and tell you that this is the y-intercept, but if they didn't, you would know that this is the y-intercept because the x-coordinate is 0. So anytime x is 0, the y is your b. Our 2/3 is m. If you know m and b, you can use the slope-intercept form to write the equation of the line. So here I'm going to write the equation y equals mx plus b. And this would be the equation of the line. Now, if they want us to write it as a linear function, the only thing different would be that we're going to replace y with f of x, because f of x means y. So here our linear function would be f of x equals 2/3 x plus 5/8, and we're done. For the next example, number 11, it says find an equation of the line having the given slope and containing the given point. We can see that this ordered pair is not the y-intercept because x is not 0. So this is just a generic point on the line. I'm going to label that x1, y1 because it's the first x and the first y. In fact, it's the only x and y that I've got. And if you're given a point and the slope, you're going to use point-slope form. And so that's going to be y minus y1, which is 6, equals m x minus x1. And then technically that's done, but most of the time they want you to rewrite that in slope-intercept form. Like on an exam, they're probably going to say, write your answer in slope-intercept form. And if that's the case, we've got a couple more steps to do. So we need to distribute the -3 and move the -6 over. That'll get the y by itself. And using the distributive property, that's going to give us -3x. Negative times a negative, that's a plus 27. Plus 6, because the -6 comes over. And then we need to CLT. We need to combine like terms. -3x plus 33. And there is the equation in slope-intercept form. Okay, for our next example, number 17, this one's going to be a little tricky because notice the slope they've given is 0. If the slope is 0, that means your line is horizontal, and the equation of any horizontal line is always y with no x. So this is going to be y equals whatever the y coordinate is. And believe it or not, that's done. That one is super easy. Now, let's assume for a second that I didn't realize the shortcut and I went ahead and worked it out anyway. If you realize that the x coordinate is 0, so the -7 would be, well, b, you could plug into slope-intercept form, y equals mx plus b, but 0 times x is 0, and you can get the same answer. And you can also get the same answer by plugging into point-slope form, where this would be x1 and y1, so it would be y minus y1 equals m x minus x1. But what is 0 times anything? Well, that's 0. And two negatives here make a plus. And then if I get the y by itself, moving a +7 over makes it -7. So do you see that I can get the same answer using any one of these methods that we've talked about? All right, let's try another one. Number 19. Here we're given a point and the slope. They want us to find the equation of the line. And since the x coordinate is not 0, then this is not the y-intercept. So I'm going to label my point x1, y1. And remember I said if you're given a point and the slope, you can use point-slope form, which is y minus y1 equals m x minus x1. And then watch how easy this is, okay? y1 is -2, so y1 gets replaced with -2. M is 2/3, so m gets replaced with 2/3, and x1 is 1, and so x1 gets replaced with 1, and that's the plug and play done. Now we need to write that answer in slope-intercept form. So we're going to use the distributive property, and we're going to bring the +2 over. So here we go. 2/3 times x is 2/3 x. 2/3 times -1 is a -2/3. And remember, this is a +2 because two negatives make it a plus. Bringing it over makes it -2. And then for the last step, to simplify, we're going to need to combine like terms. Now, some of you may be thinking, I'm not really good at adding numbers that are fractions. And guess what? That's okay. That's what the calculator is for. So we can take our calculator and go negative fraction 2/3 -2. And the calculator is going to take care of doing the common denominator and simplifying for you. And it's okay to leave this as a fraction. So that's going to be -8/3. And that is the equation of our line. For number 27, here they give us 2 points on a line, and they want us to find the equation of the line. So anytime that I start off with 2 points of a line, the first thing I need to find is the slope. So I'm going to label my points first. x1, y1, x2, y2. Label your points first, and then plug and play. Into the slope formula, that's going to be y2 minus y1 over x2 minus x1. And then you just need to work that out. Okay, so two negatives make it a plus. -6 plus 3 is -3. Two negatives make it a plus. -4 plus 2 is -2. And a negative over a negative makes a positive. Now that is not the answer. That is the slope of our line. And now what I want you to notice at this point, we now have a point and the slope, and I can use point slope form. And that's going to be y minus y1 equals m x minus x1. And then simplify. Again, two negatives make a plus. That's going to be y plus 3 equals 3 halves x plus 2. And then to simplify that further, we're going to need to distribute the 3 halves, bring the 3 over so that we can get into slope-intercept form. So we're going to have 3 halves x plus 3 halves times 2, that's 3, minus 3 from the plus 3 coming over. Oh, and look at this. 3 minus 3, those cancel. So our equation simplifies to just y equals 3 halves x. And that is the answer. Okay, pop quiz. What is the y-intercept for this equation? Did you notice there's no value for b? And so if they ask you what is the y-intercept, that'd be super easy. Well, b is 0. So that means that this equation would go through the origin. For these last two examples, we're going to look at finding the equation of a line parallel to a given equation or perpendicular to a given equation. So here for number 35, the first thing I need to point out is this symbol that looks like two parallel lines. That is the symbol for parallel. And sometimes they'll show it with those lines being straight up and down. Sometimes they're slanted. But that is the symbol for parallel. So here's the fact you need to know. Parallel lines have the same slopes. If two lines are parallel, their slopes will be equal. And so what the instructions say here, it says find the equation of the line parallel to this equation, but passing through this point. So what we're going to need to do is we're going to need to take this equation and get it in slope-intercept form. Then we can find the slope, and then we will have a point and the slope, and we can find the equation of our parallel line. Okay, that's the objective. Here we go. To achieve that objective, we're going to take the 5x over, which is going to make that minus 5x. And that'll give us negative 7y equals negative 5x plus 8. Then to divide everybody by negative 7, that will get us into slope-intercept form. Negative over a negative makes a plus 5/7. And a positive and a negative here makes a negative 8/7, which I could care less. I could really care less about the negative 8/7. You know why? Because I'm only interested in the slope. So here's what we need to know, okay? We're looking for the equation of the line parallel to this equation. So what is the slope of this equation? It's 5/7. So what would be parallel slope to that? Well, remember I said parallel lines have the same slope. So the slope of my line is also going to be 5/7. Because the lines are parallel, They have to have the same slope. And now if you look what I've got a point and the slope. I can use point slope form. And that's going to be y minus y1, which is -1, equals m 5/7 x minus x1, which is 2. And then I need to take this answer and rewrite it in slope-intercept form or standard form or whatever form they ask for. So 2 negatives make us a plus. The 5/7 needs to distribute, and the plus 1 needs to come over. So that's going to give us y equals 5/7 x minus, now look at this, 5/7 times 2. And when you multiply fractions, you multiply the tops together and the bottoms together. So that'll make a -10/7. And then the plus 1 comes over and makes -1. And then I'm going to need to CLT. I'm going to need to combine like terms. All right, so my final answer is y equals 5/7 x minus 17/7. And again, if you're not sure about doing this arithmetic, that's perfectly fine to use the calculator for that. Now, as a bonus for this one, let's assume that they said the answer needs to be written in standard form. So how could I go from slope-intercept form to standard form? Well, the first thing I would need to do is get rid of those fractions. And that means I'm going to need to multiply everybody by 7. Okay, so that's going to give us 7 times y, which is 7y. 7 times 5/7 is 5x. And 7 times 17/7 is -17. Multiplying through by 7 gets rid of the fractions. And then I'm going to need to bring the 5x over. But that'll make it -5x plus 7y equals -17. And then the 5x needs to be positive. But that's super easy because all I have to do to change that is just go through and change all the signs. So this here would be the slope-intercept form of the answer. And 5x minus 7y equals 17. That would be standard form. And just for fun, I thought it might be interesting to verify this information with Desmos. So what we're going to do to check our answers with Desmos is we're going to input the original equation. That's the original equation that we needed to be parallel to. And then I'm going to input my slope-intercept form answer. And I want you to notice that this equation does run parallel to the original equation. So do you see that the parallel aspect is verified? But what about the fact that it had to go through the point 2, -1? Well, I can go to Desmos also, and I can type in the ordered pair 2, -1. And notice that that point does fall on the blue line. And so not only is the blue line parallel to the original, but it also goes through that point. Both of those criteria had to be met. Now, one other thing I want to do here is I want to verify that my standard form answer is also correct. If I type that in, And if I turn off the blue graph, you can see that the purple graph is the same as the blue graph. Can you see that? Blue and then purple. And they both go through this point. So what have I done here? With Desmos, I have verified that my slope-intercept form and my standard form are equivalent. They make the same graph, but they are also parallel to the given equation, and they pass through the point that they needed to pass through. I don't know if you fully appreciate what Desmos does for us there. That is fan-freaking-tastic. And for the last example in this lesson, number 41, they want us to write an equation of the line containing the given point and perpendicular to the given line. So the first thing to point out is this is the symbol for perpendicular. An upside down capital T means perpendicular. And so you need to know what is special about perpendicular lines. Perpendicular lines have negative reciprocal slopes. So if you have a line that has a slope of, say, 2/3, the perpendicular slope to that would be the negative reciprocal of 2/3. So first of all, the word negative means it's going to become opposite, and reciprocal means flip it over. I'll tell you what, I'll give you a poem to help you remember. Perpendicular line, flip and change the sign. It'll work every time. Okay, so now that we have that bit of information, what is our objective here? Our objective is to take this equation and get it in slope-intercept form so that I can find the slope. And then since these are going to be perpendicular lines, I'll need to take that slope and flip and change the sign. Once I have the slope, then I'll have a point and the slope, and I can use point-slope form. That's our game plan. So the first step in the game plan is to get this equation to be in slope-intercept form. I'm going to start by moving the 3x over, which gives me 4y equals negative 3x plus 5. And then I'm going to divide everybody by 4. And that'll get us into slope-intercept form. Y equals negative 3/4 x plus 5/4. And remember, the only piece of this that I really care about is the slope. So now remember, these lines are going to be perpendicular. So if the slope of this equation is negative 3/4, what would be the perpendicular slope to that? Perpendicular line, flip and change the sign. It's going to be positive 4/3. Now that I have a point and the slope, I can use point-slope form. So let's label my point first and then plug and play. Y minus y1 equals m. That's my perpendicular slope. X minus x1, and I'm done. At least I'm done for point-slope form. If they want the answer in slope-intercept form, you have a couple more steps to do. So here, two negatives make it a plus. We're going to distribute the 4/3 and bring the 2 over. And that's going to give us 4/3 x minus. Now 4/3 times negative 3. The 3's will cancel and leave us a 4. Minus 2, because that was a plus 2 coming over. And then I need to CLT. I need to combine like terms. 4/3 x minus 6. And remember, that is my answer in slope-intercept form. What if I need the answer in standard form? Well, I need to get rid of the fraction first, which means I need to multiply by 3. Everybody needs to be multiplied through by 3. And that'll give us 3y. Here the 3's are going to cancel and give us just 4x. And 3 times 6 is 18. Now, remember, we're going for standard form. So we need to move the 4x over. That'll make it negative 4x plus 3y equals negative 18. But the a needs to be positive for standard form. And so we're simply going to go through and change all the signs. And so my final answer for standard form will be 4x minus 3y equals 18. That is the way you write the answer in standard form. And we're going to check with Desmos. So the first thing I want to do is input the original equation, the 3x plus 4y equals 5. And then I'm going to input my slope-intercept form, y equals 4/3 x minus 6. And here what I would like you to notice is, if you look at the intersection of these two lines, do you see it looks like they're a perfect plus sign? That means that they're going to intersect at a 90-degree angle, which means they are perpendicular, which is what it needed to be. It needed to be perpendicular to the black line. So my red line answer is perpendicular to the black line, but does it go through the point it needed to? Well, let's check that. 3, negative 2 in Desmos. That blue dot should be on the red line if I met the criteria, and it is. So not only is my answer perpendicular to the given line, but it does go through the point that it's supposed to. And for the final check, we're going to make sure that I didn't screw up my standard form. So we're going to type in 4x minus 3y equals, you can see the green line and then the red line. See, they're exactly the same line. So that means these answers are identical. They're just in different forms. And that verifies all of my work is correct. Every criteria is met. And we're done. So if you have any questions or comments about anything I've done, please feel free to leave that in the comment section below, or you can text me. And thanks for watching.